All right, well, welcome everyone to the Hyperion Research Briefing. I'm Patrick Gerst with CPC. I'm the general manager of our thermal management business. At CPC, we make quick disconnect couplings. Been in the market for many years. If you want to check out our products or some information or talk with some very knowledgeable people, we have folks around the entrance. We're happy to host this morning's breakfast. Who was at the opening gala last night? Lots of hands. Packed. So we're hoping to continue that energy this morning. The work Hyperion does is always really impactful for many of you, and it certainly is for CPC as well. At CPC, we've been in the market a long time, just like Hyperion. Really got started when HPC was getting its foothold. CPC, in fact, has QDs in application for many years in the top 3 high-performance computers in the world, so which we're very proud of. So obviously, we expect great content as always from Hyperion. It's important for us, and I know many of you in your businesses, to understand where the market's going, where our customers are going, so that we can inform our own product roadmaps. So have some great presenters and great content this morning. Thank you all for coming. Hopefully you got breakfast and are settled in, and we're going to get started. So I'd like to introduce Michael Thorpe from Hyperion Research.
Thank you, Patrick. There are going to be some extra chairs coming in on the side here shortly, so you should be able to find a seat. And there's some onesie-twosies at the table here as well. Thank you, Patrick. Really appreciate CPC for sponsoring this morning. It's really a heavy lift, and they really make this briefing possible. Just a couple quick housekeeping things. Today's presentation will be sent out to all registrants. So if you registered on the website, you'll get it sent directly to you. Also, thanks to CPC, they are recording today's session. So if you would like to go to the website referenced here, and you'll be getting it in your deck when it comes, you could download the video of today's presentation. For any follow-ups on interest in possible studies and discussions, for a follow-on that you see from today's presentation, you can reach out to me. My email is up here. And today's briefing will conclude by 8:20. So if you're going to make it to the opening keynote, it's about a 3.5-minute, 4-minute walk to the conference center. So again, we appreciate the opportunity to be with you today. See many familiar faces. Good to see you. It's always nice to be back here at Supercomputing. We miss some of our U.S. government and international friends, and hopefully they'll be able to join us next time if they weren't able to make the trip here. Hyperion Research is the leading independent analyst firm for advanced computing. We provide data-driven market insights, technology trends, ROI impact analysis, and strategic guidance. We do this with industry, we do this with governments, we do this with academia and the vendor global community. Also, we sponsor the HPC User Forum. Early in October, we just completed our 90th in Paris, France, which was fantastic. Our next one will be May 5th and 6th in Austin, Texas. So we hope you will join us then for that. We have the team here. We're going to be hearing from our CEO, Earl Joseph. We also have Bob Sorensen, and you're going to hear from Mark Nosikoff as well. So we're excited to be here. So if we look at today's agenda, we're going to invite Earl up. He's going to cover the HPC and the AI market. Bob's going to talk about quantum computing, AI, and some of the top-of-mind surveys that we've been doing. Mark's going to give some perspectives on HPC and AI storage, interconnects, and HPC AI clouds. Then at the end, we're going to wrap up and do the innovation awards and conclusions. So sit back and enjoy, and with that, I'm going to introduce Earl Joseph.
Great, thanks, Mike. Can everyone hear me okay? Okay. So we've got a lot of slides and information today, so if you have any questions about the charts we're showing, the details on that, please let us know. What we're doing is we're doing a snapshot out of large databases, different studies we've done, and so there's behind each bullet on each slide, there's a whole lot. I'd like to start with some major trends in the industry right now. The industry has changed from a 7 to 8% growth rate to now over 20%. In the last 2 years, we've seen just an explosion in on-prem purchases, an explosion, of course, everyone hears about the AI portion, and the use of cloud computing for technical computing. We're seeing these new technologies pop up all over the place, but also governments around the world are investing just tremendous amounts in HPC and in AI. The exciting part to us is with all the excitement around AI has brought a new attention to what high-end computing can do with large-scale computing, large-scale databases. So kind of under the coattails of the AI excitement, we're seeing this explosive growth in HPC right now. And as I mentioned earlier, the cloud computing is becoming very strong in the market, and I'll walk through some of those numbers. So last year, we saw 23.4% growth in on-prem HPC systems. This is the highest growth we've seen in the last 3 decades. And again, as I mentioned earlier, the market typically has been growing around 7 to 8% a year. We also saw over a 20% growth in the use of cloud for high-performance computing applications. So when you combine all that together, the market now has reached $60 billion. So just a tremendous amount of investment taking place on the HPC side. This is how the market split out last year by the different vendors. You can see Hewlett-Packard is the clear market leader right now, with Dell, Lenovo being very strong. Inspur in Japan is doing quite well, and Atos also, but here's the list. The thing I want to draw attention to here, though, is we've added what we call non-traditional suppliers. So these are folks that are selling NVIDIA pods or AI systems that aren't your traditional first full-service system vendors. And we've just seen them grow tremendously in the market, and I'll show some numbers on that in a minute. Here's how the market splits between leadership computing, supercomputers, large HPC, medium, and entry level. It's based just on the price of the base system itself. And you can see that the market shares roughly the same except for the leadership category. The leadership category, of course, bounces based on how many exascale or leadership class systems are installed each year. And here's how the market's split by the different verticals or use cases. And as I mentioned earlier, if you're interested in more information, we have this going down to 28 different countries. So if you want to know which country and how it's going, we also track this over time going back about 20 years, and in all cases, 5-year forecast. But this is where we're seeing the government labs around the world just expand tremendously. That's where a lot of the heavy new AI investments in HPC are happening. I should also mention, when we refer to AI, we're referring to AI used in technical computing applications. So it's not the social media portion of AI. Now, as far as looking forward, we're expecting seeing strong growth in this year. We just finished our first half of the year numbers, and the first half of the year grew by 22%, so very strong growth right now. We are still concerned about certain things, though, as far as all the political ramifications, the tariffs, and supply chain issues, but we still expect to see this to be another extremely strong growth here. And here's our forecast. I'll walk through some forecast charts here fairly quickly. So here's our 5-year forecast of the on-prem portion of the market and these non-traditional suppliers I mentioned. So if you look back to 2020, the non-traditional suppliers really didn't matter in the market. And you can see now they're moving to be something closer to 25% of the market within 5 years. And then we also try to compare when people buy technical servers, are they primarily used for AI or are they primarily used for traditional HPC mod and sim? Now this is getting really hard because most of the systems have mixed use to them. So we kind of say, well, more half the time it's HPC and that. So going forward, this will be even harder. But you can see the red line is the traditional HPC applications. The gray line is the new AI-related applications. So AI within the HPC space, you can see, has the extremely high growth curve. I should also mention in these charts the announcements that were made over the last week to 10 days of 9 new large AI systems going into DOE sites. We've only incorporated part of those in these forecasts so far because we're trying to figure out, first of all, how much are they, the dollar value, when they will be excelled and accepted, and then how much of them are going to be used for technical computing within the lab or just sold out in the general as a cloud provision. So we have to answer those questions in the near future. So then if we look at the on-prem server hardware and add in the storage portion, which is always growing very fast, the different software and then maintenance, this is what the overall on-prem market looks like and our forecast for the next 5 years. We're expecting this to get close to, by 2029, to $100 billion. Again, dramatic change in our forecast here based on all the new growth rates. Now, changing gears to cloud, and Mark will be covering cloud computing in much more detail, but just a high-level forecast is what's going on. The blue is the industry users, the orange is the use by government, and then that small gray line is academia. So academia still hasn't moved to the cloud as much as other sectors have. There's a host of reasons for that. I should also add in this chart that we expect to see some tipping points. As AI becomes more productive and some other reasons, we expect that the cloud could very much see another growth spurt on top of what we're showing here. And then this is the total market when you take the on-premise and the cloud computing together. And again, that's getting close to 120 billion by 2029. So next, I'd like to spend just a little time on some research we've been doing, and I want to thank DOE for sponsoring us for the last 10 years for doing what is the ROI for high-performance computing. And how do you compare leadership sites, and how do you really show your funding bodies, politicians, and other people what's the value of high-performance computing? And so what we do is we look at the end success stories. Here's a successful new car tire, a new successful car design, a new successful weather forecast, and then we rank them by how important the discovery was. In the last 10 years, was it one or two top innovations? Was it one of the top 5? Was it one of the top 100? And then we also look at how impactful is it? Is it only knowledgeable and useful to one little group of 4 or 5 people? Is it useful for 10 people, 100 people? And that's where you see this class rating we've come up with from class 1 to class 8. And I want to thank Riken and NERSC for allowing us to share their data. So in this chart, each of the black dots represent a separate successful product using high-performance computing. And for the community, we're making this database totally available. In this chart, it has 650. We're at around 725. These are fully profiled success stories. What industry, what they actually accomplished, the dollar value, how much computing they used, and so on. And the white dots here are the Riken programs. Now, you'd expect this in a national supercomputer. Riken is one of the most expensive supercomputers. It was a little bit over $1 billion for an on-prem system. And you can see they very much bunch in the upper right corner and in the upper portion of the chart. And we did a similar thing for NERSC last fall. And you can see, again, it shows the leadership relative to overall industrial use of that. And we're planning in the coming year to take this whole ROI research to the next level to actually calculate the ROI value of more just pure science discoveries. And we'll be showing that in the near future. And so with that, I'd like to hand it to Bob Sorensen to talk about quantum computing, AI, and top-of-mind findings.
Thank you.
Thank you.
Nice job. Hi, I'm Bob Sorensen. I like to tell people that when I started doing this kind of work, when I had less gray beard and more brown hair, the job was a lot easier because you had one question answered: do I buy a Cray or not? And the world has really moved on, and as I was putting together my portion of this, I realized, wait a minute, I'm going to be doing quantum computing, AI, and a little bit of top of mind, which covers cloud and HPC. So it kind of covers the spectrum of what this sector has become. It's no longer just Cray or not, it's where do I write? What do I run on? What kind of system do I use? What technology do I use? What fundamental compute phenomena do I rely on? Is it binary digits? Is it photon quantum computing stuff? It's a really interesting time to be doing this kind of work. So we're going to go through a whole bunch of stuff very quickly, and we're going to go forward instead of backwards. So one of the first things I want to cover is what's going on in the quantum computing sector, because it's interesting to be able to address the HPC crowd, because I just want to tell you that the time is now. It's really time to start preparing. And I'm not going to recommend that you go out and buy a quantum system today. What I'm going to recommend is you start to think about what quantum can do for you by looking inward. Look at what your workloads are, look at your pain points, and start to figure out what quantum can bring to your particular computational workload. And only then do you start to think about what vendors, what technologies, what modalities, and ultimately what's your on-ramp to think about quantum. So the message here is it's really time to start thinking about what quantum can bring to your computational workload. So I just want to give you a quick overview of what's going on in the quantum market. It's really right now about $1 billion market in 2024. We're looking at a reasonably good growth rate, about 27% compound annual growth, at least for the next few years. Interesting, we go out and we survey quantum computing companies to actually get some of their insights. So we have a better sense of what's going on because it is a very nascent sector. We want to get the exact sense of where the sector's going. A lot of organizations out there see revenues increasing rather significantly in the next few years. The number of firms that have flat or nearly the same revenues have dropped from about a quarter to less than about 1 in 11. And that's a big deal because when we first started this a few years ago, more than half of the quantum computing companies out there had less than $500,000 a year in revenue, and about a third had zero revenue. So the sector is starting to generate some interesting revenue going forward. The way that quantum computing companies are operating right now, the way they're gaining expertise and capabilities to address the HPC sector is through partnerships, whether it be through a government lab for a research project, whether it be for another quantum computing manufacturer to help fill out their product stack, if you will, and ultimately to partnerships with quantum computing end users. Quantum computing companies are at the stage now where they're thinking about how do I develop vertical specific expertise? Because as I've told a number of quantum computing companies, you can't go to an oil and gas company on Monday, a pharmaceutical company on Tuesday, and an aerospace company on Wednesday and speak the same language. You have to go out and understand the specifics of each vertical. And that's where a lot of quantum computing companies are really striving today to understand the specifics of what different end users want out of a quantum computing capability. Right now, quantum computing is accessed primarily through the cloud. It's a low barrier to entry, pay as you go. You can shift companies, you can shift modalities, run a job on a photonic system today, a trapped ion system tomorrow, a superconducting qubit the next day. We expect that on-prem procurements are going to start to increase in the next few years with a high degree of enthusiasm. Right now, the big three, the holy trinity, if you will, of quantum computing applications are ModSim leads the way, molecular dynamics, computational chemistry, looking at development of advanced materials by going literally down to the molecular level. Optimization is a huge capability, not only because the sector in the classical world has kind of been stuck in optimization technology for a number of years, but it has such widespread application. There is literally no commercial enterprise out there that can't benefit by optimizing some particular portion of their overall business process. And the other one is machine learning, artificial intelligence. That to me is a distant third. I think it's more about trying to grab onto the tail of the AI enthusiasm more than it is about demonstrated capability. There's some other stuff here that we can just go through. The only thing I really want to talk about that this really highlights is the one at the very bottom. There has been some real concern here that large language models and AI is the near-term bright shiny object in terms of performance and grabbing budget. And so there is some concern within the quantum computing sector that the current enthusiasm for AI is going to slow down the interest and adoption of quantum computing. We haven't really seen that yet. It seems that money seems to come up for both of these things, but it is, at least for the next few years, somewhat of a lingering, nagging concern. We've done this estimate for the last 5 years, again, based on surveys with organizations. We literally just launched our 6th annual survey funded by the US government to do the market forecast again, and we hope to reach a significant number of companies, not only in the United States, but we're getting great support from the EU, Canada, Australia, and Asia Pacific organizations to help us build this market survey. Interesting things, just some key points about what's tough about the quantum computing sector right now. As I mentioned, installations are coming to the fore, and a single installation can significantly change the financial position. One of my favorite examples is, D-Wave books a $23 million system to go down in Huntsville, Alabama. That gives them a 120% increase in their revenues for the sale of one installation. The other thing that you have to watch out for when you look at revenues is, and I didn't want to put the companies up here because it's not terribly relevant, but you get a press release that says, hey, we made $10 million of revenue last year, but we lost $201 million in the process. That's something you really have to look over pretty carefully. Still, a lot of companies out there are private, and that means that they're still highly dependent on venture capital and government programs to maintain income revenue or to maintain resource revenue as they move forward. This is just a quick summary of the kind of money that's flowing into the quantum computing sector right now. And I put this up here for two reasons. One, there's still some active investment going on here. And two, some of these numbers are scary large. The VC community has decided that some of these organizations have a valuation of multiple billions of dollars right now. And that can be a scary thing. If one of these companies actually has a down round, they go for more money and they can't get what they want, will it be viewed as a harbinger of problems in the quantum computing sector or merely a culling of the herd? And to me, that's a big issue right now because, and this is interesting, right now there are 84 quantum computing companies in the world that supply or offer or pretend to supply quantum computing hardware. 84 companies. That's if you take the sum total of all companies that ever said they were an HPC vendor. Since Seymour Cray designed a 6600, you don't get 84 companies. There must be a culling of the herd. There has to be mergers and acquisitions. There has to be consolidation. So look for those things. It doesn't speak to the weakness of the sector. What it does is it speaks to the fact that the sector is becoming more efficient. The winners are rising to the top, and the losers are hopefully either going home or reconfiguring or being absorbed by another organization. So there's lots of dynamics in the sector. Next thing I want to talk about is AI, and we just finished an interesting report, and it was done by one of our junior analysts, Tom Sorensen. And really what we wanted to do is find out what's going on with HPC and artificial intelligence going forward, and really try to figure out what are some of the investments that we really need to be thinking about, and what are organizations finding when they use, actually, we focused down on generative AI to be specific. And so we came up with a lot of these things about what are you using? We talked to, I think, 103 different HPC end users, again, specifically targeting HPC end users and generative AI, which nowadays generally means, or almost exclusively means large language models. And we asked them, what are you doing with this capability? And you'll see here that the big choices, of course, are data analysis, whether it be pure scientific data or time series, followed by text, whether it be open text analysis or summary, or the single most rigorous kind of text, which is programming languages. They have great syntax. They have relatively easy semantics going forward. That's really what's being done right now. It's more about data analysis, and it's more about text summarization and such. We haven't seen a lot of evidence that generative AI is being driven into some of the modeling and simulation capabilities. They may run in parallel as, say, a digital twin. They may generate some synthetic data, but they haven't actually delved down deeply. No one's unrolling a triple nested do loop in their CFD code to inject large language models into it. It's more of a companion, an optimizer of sorts than it is replacing traditional HPC. When we asked about expectations for these organizations that were looking at large language models, most of them said it's either moderately exceed expectations or greatly exceed expectations. So really, organizations, and part of this comes to me is HPC users are relatively smart. They know what they're after before they go into this. So the fact that everyone said this is pretty much what we suspected is something that we pretty much expected, because organizations like HPC guys, they know what they're looking for. They know what they expect out of this. Now, the other point about this is they said, look, we're out there, we're going to expand, but we found that almost half of them said we're going to moderately just go forward. And about 1 in 5 said we're going to continue at the same level. So while we're, as Earl mentioned, the acceleration of generative AI, we think a lot of that's being driven by interest in the enterprise space, where there's going to be moderate growth going forward, a little bit of slowing down, a little bit of, for lack of a better term, sanity returning to generative AI in the HPC space. And one of the reasons for this is we talk to organizations, says, let's talk about return on investment, visible displays of the usefulness of what this brought to the table. And what we found is about roughly half the respondents expect a measurable ROI within 2 years, with about 1/3 in less than 1 year. So there's a certain sense of, yes, we're in this, we have to be in this at least for a few years before we can demonstrate that there's value here. One of the things that we thought was really interesting is that a lot of organizations have found that this was significantly more costly than they expected, either moderately or significantly, and about 1/3 said met expectations. And we were kind of scratching our heads over this, because it seems that anybody that gets involved in large language models and Gen AI a priori has to know this is expensive. And so the fact that so many organizations said it exceeded our expectations for cost, as Tom said, we were reviewing this. It's like someone saying, I didn't expect the fire to be so hot. And that's really what I think we've got here. It's like you were surprised that this is going to be an expensive operation. What I like about this particular graphic is when we asked about what are some of the challenges and roadblocks, and it is kind of an eye chart of sorts, which speakers always apologize for. But the bottom line is there's no single pain point here. Everyone kind of has a different place where they're like, wow, this is something that we need to be thinking about more. And really what you see here is, and this is a classic HPC answer, complexity with integration. Organizations are always very loath to any new technology and what it's going to take to actually drive that into their existing compute environment. And we always get that. But again, the depth and breadth of the different pain points here, I think, is illustrative of some of the complexities that are going forward in the HPC space when it comes to driving large language models into their workloads. This is our top of mind study, and I have a homework assignment for everyone here in the room. We do these now every 3 or 4 months, and they're 5 short questions. And according to SurveyMonkey, it should take you 80 seconds to fill out the answers to this. And they're very capricious in some sense, but we're really trying to capture the mood of the world at any particular point in time. And so we're going to release our 3rd top of mind study in a few weeks. So the 2 homework assignments is A, if you have a top of mind question, and I'll show you a couple in a second so you get a sense of what we're looking for, drop me a note. We'll see if we can put it in. We, as I said, 5 questions. And the second one is when, not if, but when you get the invitation to take the top of mind survey, please do. The more answers we get, the more validity we feel we have. So here's just a couple of samples. And this is one we did a couple of months ago. It says, in which areas do the major CSPs need the most improvement? And what was interesting is we said, pick 2 choices here. And these are all the choices we gave them. And about 30% of the respondents mentioned lower cost, either for storage or compute. But about 15% used both their choices to say lower cost for storage and lower cost for compute. So cost is certainly a thing, and if you run your eye down some of these other choices, there are other cost elements in here. So you can kind of reach the conclusion that, yeah, there's some certain enthusiasm for clouds, but the cost issue still remains to be perhaps one of the most pernicious. But what was interesting is about 13% of the respondents, even though we gave them what we thought was a relatively wide spectrum of choices, about 13% used the other option to write in even more problems that they had with CSPs. And that really tells you, again, from a solve the problem perspective for cloud, it's not something where you can implement a single change and solve everyone's problems. There's lots of concern here going forward. And when people say, well, why aren't the HPC end users more enthusiastic about cloud? I mean, to me, this kind of gives you a relatively strong indicator of what some of the concerns are. The last one that we did was, and we always hear about shortages in HPC. Where's the workforce coming from? Where do we get the people to do the work? So we said, what areas have the greatest shortage of expertise in the HPC world? And we gave them a whole bunch of choices. And you can see here, application development, probably a perennial answer, GPU expertise, domain knowledge, systems administration, cloud specialization, security. These are really consistent. And again, we had 14% wrote in other responses. And this was one of my favorite ones. 4 respondents actually said, quantum computing, that's where we need more expertise. Again, this idea of integrating a new technology into your existing workloads. And several respondents came back and said, why'd you only allow us to pick 2 here? We have a lot more concerns here. It's not, again, not a single point of failure, a lot more interest here. So I'll say it one more time and I'll be done. Homework assignment, come up with some questions that I can use. And if you see the survey, when you see the survey, please provide your inputs. Like I said, SurveyMonkey says 80 seconds. If you're fast, you can do it under a minute. Otherwise, that's it, and I'm going to turn it over to Mark Nazikov, bring him up, and he can move on to the next section.
Okay, buckle up. We're going on a nice fast sprint here through cloud storage, interconnects, and sustainability. Some of you might know and recognize I've dusted off a couple of slides from a couple years ago. Bob mentioned how things are changed. You used to only have to ask one question. Your father's HPC used to be a minimum number of technology things, but from the father's HPC, you add You add AI into the mix, and it becomes a lot more complex, a lot more intersecting and convergence of a lot of other technologies. So that's what we're going to talk about today. We'll start with cloud, and despite the top of mind survey that people shared with some of their concerns and barriers, it's not preventing them from using the cloud. And we're still seeing cloud growth, and we've been adjusting our cloud forecasts upward over the years. And here you're seeing us projecting spending in the cloud approaching $25 billion out in the 2029 timeframe. I do want to emphasize with our cloud forecasts, we talk about what users are spending to run their workloads in the cloud, as opposed to what the CSPs are spending to provision those resources. So there's a kind of a subtle difference there for how we're measuring the cloud forecasts. Earl showed a version of this that shows the entire investment within the HPC AI community of spending in the cloud, as well as resources, on-prem resources, showing in 2024 roughly 15% of spending for HPC resources was in the cloud, and that's growing at over 20% out in we're projecting in the 2029 timeframe. The sector usage and utilization of cloud, we see industry as a predominant user of cloud. Academia is growing at the fastest rate, but that's kind of the law of small numbers. Growth on a small number projects a greater percentage increase, but still that's projecting a 20%, almost 20% CAGR in the forecast timeframe. Who's leading for the CSPs? Look at the 2024 market shares. Amazon AWS is steered by and large in a large amount the market share leader for HPC resources. We have seen Google capture market share over the last couple of years, and the others are Microsoft is holding relatively flat. What we expect to see in the future, though, and what's reflected here, is a much stronger showing and much more research from the neo clouds. We expect to see more market share capture for them. I'm going to go through these in great detail. This is a perception chart of asking our users and cloud users perceptions of where on-prem is stronger. That's the blue side to the left, and where they perceive that cloud operations are stronger. And we see the access to latest technology, whether it be the LLMs or the fastest GPUs, and also the AI software stack tend to be the perceived advantages of cloud on-prem. Looking at drivers, this reflects something similar for what users are turning to the cloud for, the ability to get things done just at a scale that can't be done based on resources, what they have access to, and then also the latest technology. Barriers, this is consistent with the top of mind survey as well, perceived costs for their workloads. And migration is also a different, what changes need to be made to their application codes to move from on-prem to the cloud. I want to make note here of some kind of a coming attraction here. We've been working with PNNL very closely to develop this model to be able to make decisions more transparent about where to run your resource, about the resources to run your applications and code, making the scientific decision. So the challenges in understanding it, there's hidden costs relative to when you're making a TCO comparison. There's different planning uncertainties that are faced. You have inputs from all the relevant constituents that are involved in making that type of trade-off decision. So the solution is development of this tool based on direct research, based on a body of knowledge of direct responses for different TCO models across sectors, across different users. And so we have this continuum computing tool that we're in the process of validating that takes a whole list of questions. Some are listed here on the left that are project-specific characteristics of that particular project from how the importance of their field, perceived value of how quickly, how time to solution is critical or not, how critical it is for access to new technologies, et cetera. And then we'll produce an output of a recommendation. And we'll be refining this and validating this and coming soon to a more direct conversation to you. Moving on to storage. Earl put up the storage numbers briefly. Storage traditionally is, and it continues to be, kind of the fastest growing segment of the on-prem market. This shows the growth rate. What's interesting here, a little bit, these numbers may vary a little from percentage. The purple cloud pie piece here, it includes a storage element. When you look at the percentage of the storage market and the percentage, there's a sliver of the cloud pie that's added to the orange on-prem storage bucket. Within the cloud spending on storage, we look at the roughly a third, 30% of spending on resources in the cloud is spent on storage. And we expect that to kind of continue. As the data solutions in the past had been really focused an awful lot on speeds and feeds and on what I'd call the abilities, the RSUI, reliability, serviceability, et cetera, as well as durability was added to it. More and more, it's been up-leveled to this notion of a data platform. What used to be primarily a homogeneous workload, looking at checkpoints, focusing on high bandwidth and high availability for the systems, has now emerged with the AI pipeline with all sorts of disparate and diverse requirements placed on the storage and interconnects when we get to the interconnect section here. Some of these diverse requirements, the access pattern, access type, are they reads and writes, are they large block, small block, how much data, the size of the data, all factor into these new requirements, as well as a whole host of other things. And when we look at the vendors that are producing and providing these solutions, they've almost to a single one, they've all adopted this move to a data platform rather than just thinking about it as storage. Some of these are stronger and more advanced in the data platform. We see VAST as being a strong adopter of the data platform with their AI operating system. GDN's recently with their Infinia establishing some traction, as well as the others that are listed here. Moving on to interconnects, driven in large part by all those other requirements, we see a hierarchy of interconnects, which adds to the complexities from those first couple of charts. So the interconnects, can drill down into the system, down at the chiplet level, moving up to rack level and shelf level solutions, interconnects there, then moving up to cabinet, and then connecting across cabinets and then even across regions. The notion and evolution of scale up, scale out, scale across lead to a number of different interconnects that are listed, and that's driving an awful lot of standard activity. We see the emergence of the Ultra Ethernet Consortium, which has strong support with folks introducing and contributing to it. An awful large part of it is maybe of some surprise or note is based on Slingshot, HPE making significant contributions to the UEC. Most recently at OCP conference, a new scale-up networking standard has been introduced there, eSUN, and that's also in addition to the Ultra Accelerator link that has been introduced and folks are working on to compare and contrast somewhat with the NVLink, which given NVIDIA's dominance in the market, NVLink is a de facto standard with interconnects at that particular level in the system. Quick note for the leadership, you can go back and look at that to see who's playing where. You'll see a number of organizations are contributing to that. Other consideration, other interconnects. I mentioned Slingshot. We've got BXI. Evident BXI has their own interconnect. Omnipath is making progress, continuing their roadmap. Huawei has made some announcements of coming out with an intent to challenge NVLink. And the CSPs, in large part, many of them have their own bespoke interconnect that are trying to address with the primary objective is to keep the GPUs fed, keep them highly utilized. The last note I want to make here is that the technology optical adoption. We're seeing more and more activity and more from cost effectiveness to supply, breadth of supply for all the optical components beginning to really gain traction and appearing on system roadmaps. Looking at some charts here that can go back and look at more detail. Different ways to slice and dice and cut what interconnects, how they're faring out in the market. If you look at this particular one looks at the top 20 systems on the top 500 list as of June. Did not have time to update it from yesterday's announcement if there's any changes. But with the emergence of the U.S. exascale systems over the last few years have bumped up the performance that's being delivered by Ethernet and on Ethernet significantly on the top 500. Other ways here, we also tend to think that they may be looking at just when systems first appear is another way to get a sense of where interconnects are faring, and we'll happy to have a deeper conversation on that. So what does this mean for your future? Moving, especially as systems are AI is being adopted more in the enterprise out and beyond HPC, there's a number of these higher level requirements are gaining importance. The scalability has been there. Things like security and actually the compatibility and choice is one of the a key driver of some of these standards and what we see users looking for. Just want to touch briefly on some of the sustainability aspects within the market. We've looked at several studies and what's happening. So if you look at the global stage with what's happening for renewables and the study by the International Renewable Energy Organization found that of the total global power capacity added in 2024. Renewables made up over 90% of that, which is a fairly high number. That's definitely driven more by global deployment of renewable energies, and in particular in China. And across the geographies too, and even in the United States, there's the capacity for renewable energy, but the transmission of that renewable energy capacity tends to be a large barrier for doing that. Moving forward to looking at where from the data center infrastructure. This was from a study from Lawrence Berkeley Lab last year as well, that there's probably no surprise here that traditional infrastructure that had driven the energy usage is just being overwhelmed by the multi-GPU, high GPU cluster count moving forward. That's demanding for the energy consumption. What are users thinking? What do they think about energy adoption? This came from another top-of-mind question. Bob mentioned our top-of-mind series. How likely is it that power and sustainability concerns will limit the use of AI over the next 3 to 5 years? And the predominant choice was very likely that the power and sustainability concerns will have a somewhat likely or very likely, over 70% believe that it's going to have a strong impact on kind of muting, even with the large adoption of AI, that the energy concerns are muting it. So then another question then asked of our users was, what's the willingness then to trade off performance for energy efficiency? If they feel energy is a concern and is muting them, what's their willingness to exchange, make that trade-off? And despite some of the discussion towards the energy concern, there's a very limited appetite to really give up a lot of performance to save some energy consumption. What can be done looking at new sustainability technology? There's battery storage we're seeing emerge, being evaluated and implemented, and then different and other continued cooling systems, including the Microsoft in-chip microfluidics as a new technology. Just closing out here on the last slide, some things to think about, not only from the topics I covered, but in general. We have check out our new website. We just rolled that out last week. A lot of our data comes from our periodic global site surveys. So we just recently launched our latest one, and the results from that should be available. And then I mentioned this continuum computing TCO model and tool that we're working with PNNL on. We expect to validate that and be having conversations to refine and bring that forward. With that, I will, if you have any questions, reach out to me and another one of our research colleagues, Jacqueline Ludema, unable to make the show, either one of us on any of these topics. And I'll hand it back to Earl.
Great, thanks, Mark. So in summary, as Bob was talking about, we just completed this AI and ROI study. I just wanted to hit a few of the other highlights and summary findings that were quite amazing to us. Is that 75.8% of the sites felt that their AI projects met or exceeded expectations. Now, one reason we launched this study was there were a number of AI studies done by MIT and other organizations that showed in the non-HPC space there was a lot of failures with AI. I mean, and the rates were in the 80s, 90% failure rates. And from everyone we talked in HPC, it was a whole different story. So that's why we launched this study. So we're actually saying, as Bob was mentioning, when HPC people tend to use AI, they tend to be a little more thoughtful. They've gone through, a lot of highly computational things, how you deal with data, and it costs a lot of money, so you don't do it unless you kind of figure out it's going to be useful and successful. The other part is that, as Bob mentioned too, 75% of they're planning to spend more money. So we're seeing an increase in spending right now. It's not quite as much this year as last year, but the total dollar amount still is extremely sizable here. The other one that was a shock to me is that roughly 40% of the sites are already using agentic AI models. So the agentic AI is already in practice, being used at a very high rate here. So as new AI technologies come on board, they are being adopted now much faster in HPC than the general enterprise space. But at the same time, there are a lot of technical challenges. The hallucinations, can you trust it? It's not a definitive answer in that. So AI still has a long ways to go within HPC. And in conclusions, as I mentioned, 2025 is growing, very fast. 2024 was the best growth year in, 30 years, which is quite amazing. All different sectors are doing well. Quantum computing, many systems have been installed this year. So it's probably the largest install year for quantum computing by a large amount. As Mark mentioned, the storage is growing at an extremely high rate, but there are some growing concerns around the system costs. To do AI at scale costs a lot of money, as everyone's seen, and how fast can you actually move budgets? In the US, it's been very difficult to move budgets too much, but it keeps changing. But then where do you get the power and the cooling systems? And the largest part right now is actually the talent. In the surveys we're doing, talent continues to be one of the #1 issues. 3 major factors on that. We have a shrinking HPC workforce. People are retiring, they're moving on. There's a massive increase in system complexity in new technology. So you need more people and more diverse trained people. And it requires new skills. The AI area requires a tremendous amount of new skills, new learning. It's far beyond just using GPUs to your HPC problem, the skill set required. So this is what we see as one of the major constraints in the industry right now that needs to be addressed. Another big concern that we're hearing from everyone is that the processor vendors, the system vendors that are moving away from 64-bit capabilities. Now, that doesn't mean that they're dropping and it's not there, but for example, with NVIDIA, the portion of the processor that does 64-bit is, reducing. We've seen some roadmaps where the 64-bit performance may not actually go up much, if any, in future roadmaps. So this is one of the larger technical issues in the industry right now that needs to be addressed. And with that, I'd like to switch gears to our Innovation Awards. And Mark, if you could come up and give me a hand with these. Here are some examples of previous winners. I probably have them in the wrong order, but. So we've had a lot of winners. We welcome everyone to make submissions. The way this works is this is the part of the HPC user forum, and we have a number of the steering committee members in the audience. And so maybe if you're on the steering committee, you could raise your hand at least. And so a lot of great folks here. So they make the actual decisions, and so we welcome you to submit your success stories. For the award itself, you get a nice glass trophy, which we'll be mailing to the winners in just a few weeks, and then also the certificates, which Mark will be handing out. So first, I'd like to talk about the end user award winners. We had 26 submissions, and we selected 4 of them. And the first one is related to earthquakes applied as a service. And this is the Barcelona Supercomputing Center. And if anyone from the center is here to accept the award, please, yeah, if everyone could come up front and stay up front, that'd be great. Mark, there's 2 inside of there, so they can, in each one. And then if you could stay up here too, as we call the different ones. And this was part of the European flagship project, and it delivers near real-time seismic simulations and hazard maps on that part. So our second winner in no particular order is related to real-time tsunami weather warning systems. This was with coastal waterways, and it was done on El Capitan. And so I'm not sure if anyone's here. Just if you come up front, that would be fantastic. We appreciate that. And they were able to solve billion parameter scale inversion problems in less than 0.2 seconds, which is just phenomenal. So we have 2, but we'll get the additional certificates for you. So we need in total 2, 4, 6. So congratulations. And if you could stay up, yeah, we would like to keep everyone up front here to do a couple pictures at the very end. And next we have agentic AI for biomanufacturing optimization. So I'm not sure if anyone is here from DUT. Excellent. Congratulations. Okay. Yep. Right there. Yeah, there should be 2 in there. Yeah, there should be 2, 1 for each to be in there. Then I think they're going to take some pictures. And if you could stay up, okay, that'd be great. Great, thanks again. And next we have Occidental Petroleum as far as closed loop AI-driven optimization. Is everyone here from there? I guess not, but we want to thank you anyways. We'll be mailing the award to you. Now, in addition to the end user use case awards, we do from time to time have a different reward section that's for vendor innovations. The category here is when a vendor develops something that's very large step forwards. So you usually see a lot of incremental improvements all the time, but not as frequently seeing the large steps forward. And this year we have one for NVIDIA for the Blackwell GPU itself and the Blackwell platform that goes along with that. So I'm not sure if I think there's someone from NVIDIA to come up to accept the award. There he is, there's Ian. So some of the criteria for this, as I mentioned, the vendor award has slightly different criteria. Blackwell clearly is just dramatically stronger and a major improvement over the previous Grace Hopper platform. But in addition to that, the entire platform itself really is what's shaping the industry as a whole. And we always like to, when you have what I call the global metrics for success stories and that, and one of the ones here clearly is what is the market acceptance? And the market acceptance of Blackwell, I'm not sure you can be doing better. Your problem is getting enough of them in supply chain as opposed to people who want to buy them. So congratulations again. And then Mike, maybe you get a picture of all the award winners. Okay. Great, and just to thank you again for your tremendous successes. And with that, I'd like to thank everyone for joining us. Sorry, we're just a couple minutes over, but you should have time to get back to the keynote if that's your plans for today. And if you have any questions or anything, please come up front.